Here's problem 1213. A 25-foot long crane supported at its lower end by a pin is elevated by a horizontal cable as shown in the figure. A 250-pound load is suspended from the outer end of the crane. The center of gravity of the crane is 10 feet from the pin, and the crane weighs 200 pounds. What is the tension in the horizontal cable? First thing we want to do for any problem like this is a free body diagram, because that will help us set up our equations that we need. Now we're told that the center of gravity of the crane is 10 feet from the pin, so it's really kind of skewed. It's not a uniform crane, and so we can treat that the weight of the crane is acting at that point. So at 10 feet up on the crane, we have the weight of the crane, which is 200 pounds. We also have a force at the end of the crane, which is the 250 pounds. Also acting at the end of the crane is the tension force along the cord, which is going horizontally to the left. We'll just call that T, and that's going at a would be a 30-degree angle to the horizontal. And then we have some kind of reaction force at the pivot pin. We don't know what that is, but we'll assign it vertical and horizontal components to that reaction force. Horizontal component coming off, 30-degree angle for the crane. Okay, so this is a good free body diagram showing all the forces, and they're all in the X and Y direction, so that's kind of nice. Now, if we were to calculate torques, we would probably choose one of two major points, maybe point A or point B, because we have two forces acting at both of those points. And we don't know V and H, so A is a good choice because that would eliminate V and H from consideration, because their line of actions go through point A, and hence they have no moment arm, so no torque due to V and H at point A. So that's what we're going to do. We're going to select point A. Now let's calculate our moment arms. For point A, the moment arm for tension, T, will be this distance right here. And that's the same, if I look at this triangle, as this distance over here. That's going to be equal to 25 feet sine 30 degrees. So let's calculate what that is. 25 feet times the sine of 30 degrees is 12.5 feet. Okay? We want the moment arm for the weight of the crane. That's going to be from the pivot point to the line of action of that weight. This is the line of action here. And so that distance is going to be 10 times the cosine of 30 degrees. That's going to be 8.66 feet. And then we want the moment arm for this 250-pound weight here. There's the line of action. From the pivot to that point is this distance right here, and that's going to be 25 feet cosine 30 degrees. And what is that? 25 feet times cosine 30 is 21.65 feet. Alright, so those are the moment arms for the forces that are causing torques about point A. If I did a quick torque diagram, it might look something like this. Here's point A, and up here I've got a tension force with a moment arm of 12.5 feet. And then over here I've got a 250-pound force with a moment arm of 21.65 feet. And then here I've got a 200-pound weight force with a moment arm of 8.66 feet. Okay, the tension force is trying to make this thing rotate counterclockwise about point A, and hence that would be a positive torque. And the other two torques are trying to make this thing rotate clockwise about point A, and so those would be both negative torques, because they're trying to make it rotate clockwise against counterclockwise. The summation of all these torques should add up to 0. So the summation of all the torques about point A is equal to 0. My positive torque is moment arm times force, so we got 12.5 times T. And then I have my two negative torques. I got a 21.65 moment arm for the 250 pounds, and then I have an 8.66 moment arm for the 200 pounds. I have a bunch of numbers in T. I can solve this for T. So T is going to equal 21.65 times 250 pounds plus 8.66 times 200 pounds divided by 12.5. The feet will divide into feet, and they'll be gone, and I'll be left with units of pounds, which is a unit of force. So that'll be all right. 21.65 times 250 plus 8.66 times 200. All that divided by 12.5. I get 571.6 pounds. So the tension force in that cord is 571.6 pounds. That is our answer. That is the tension in the horizontal cable, and so that is answer D.